Supplemental math videos from Circle Christian School. Multiplying polynomials. Beware the binomial squared. The whole purpose of adding, subtracting, multiplying, and dividing these big old hairy polynomials is the fact that we're just using real number operations, but these have possibilities. All right, we're going to do that distributing, combine any like terms. It's just number to number, letter to letter. Remember, I like to do my little circles here, show my eyes where to go with my little rainbows. All right, up. And we're just going to multiply. So we get a negative 12 x to the 4th power plus 6x to the 3rd power minus, watch the signs, 3x to the 2nd power minus 3x. Number to number, letter to letter. All right, when we do binomials multiplied to another binomial, then we're doing that super distributing and combining like terms. Everybody in the first bubble gets distributed to everybody in the second bubble. That foiling thing. First, outside, inside, last. All right, so I'm going to get a 6x squared minus 4x. And I like to use a different color. That's what's kind of cool about those clicky pens. And I'm going to distribute the next guy to everybody inside. And we get a negative, a positive 3x. Gotta watch my signs here. And 1 times the negative 2 is negative 2. Gonna combine my like terms here. Remember, it's super distribute man. And we get 6x squared. Combine our like terms. Minus x. The coefficients are the guys that get added together here. And minus 2. Okay. Then we have a couple special binomial products. They're so special, they're actually called special binomial products. First one is the 2-second one. You can always recognize this because it has the plus sign and then it has the minus sign inside here. You just square the first one, so we'd get a 4x to the 2nd power. Square the last one, which would be a 9, and you put a big old minus sign right in between it. And then we have the other special one, the binomial squared, the one you're supposed to watch out for. Simply put, you have to remember that it's a binomial times a binomial, and it's always the first guy squared. The 2 inside happen twice, 2ab, and then the last one squared, like so. So that's the pattern that happens with it. First guy squared, twice the middle, last guy squared. Another way to multiply these together is a lot like the Punnett square that you use for the recessive genes and the dominant gene type of thing. We have the first binomial times the other binomial, and I'm just going to split it up into square form here. And first I'm going to take this guy here and multiply it to everybody into the squares, and this would give me a 6x squared. And we multiply it to the negative 3, so it'd be a negative 3x. And then we're going to take this guy and multiply him to everybody on the top there, so that's going to give me a positive 2x. And then to the negative ones, negative 3, like so. And the diagonal squares, the ones that are in yellow, are the guys that we add together. So you get a 6x squared minus x, because that's negative 3 plus 2, and minus 3. Just another way to do it. Kind of fun also. All right, here was the exit problem that we had. a plus b to the fourth power, which would mean a plus b times a plus b times a plus b times a plus b. Or you can get kind of clever here, and it'd be a plus b squared times a plus b squared, and use our little pattern. So I'm going to do the first one squared, twice the middle, and the last one squared. And that's going to get multiplied to the same thing, because we already know what it is, so we only had to do it once. Plus the b squared. Okay, now here's the tricky part. We're going to have to super distribute. And so I'm going to take the a squared and give it to everybody. Try doing each one of these on their own. Don't try to put a whole bunch of arrows down until you're ready to do that certain number that you're distributing. So I'm going to get a to the fourth power and plus 2a to the third power and b, and plus a squared b squared. You'll start to see a little bit of a pattern here. And then I'm going to take the middle guy and I'm going to distribute him to everybody. I'm going to follow my green arrows this time. And I'm going to get a positive 2a to the third power and a b. Putting my like terms underneath each other, it really helps instead of having them all spread out. And plus a 2a squared b squared and a plus 2a b to the third. And now we're going to do the last one. We can go underneath for that one. Follow all my yellow arrows. And so I'm going to get a positive a squared and a b squared. Put the a first, plus a 2ab to the third power. Notice how there's a little pattern happening here. Plus b to the fourth. And now we're going to combine all our like terms. We super distributed. And so we have a to the fourth power plus 4a to the third b plus 2, 3, 4. I should have 6. Why do I not have? I should have 2's in there. Oh, doggone it. 2 and 2. I see it. That should have been a 4. Okay. My bad. 2 times 2. And so we get 6a squared plus b squared plus 4a b to the third plus b to the fourth. Notice there's a little bit of a pattern here. When we get to chapter 10, I am, and Dexter had to get his 2 cents in while working this problem, but when we get to chapter 10, you'll find there's a really cool way to do these easily. But you'll notice that we have to the fourth power. Okay, so those are a match up here. We have some coefficient things happening, and we have some power things. We have the 3. We have a 3 here and a 1, which equals a 4, a 2 and a 2, which equals a 4, a 1 and a 3, which equals a 4, and then of course we got that cool little 4 that we had on the front and the back. Okay, guys, go Super D.